We're going to take a look at 7.1 and 7.2. 7.1, you should be going through the chapter 7, day 2. If you go through the book, you can fill in the blanks. 7.1, just talk about it real quickly, and then we'll get on to 7.2 because they're very related. 7.1 is about transformations, which is moving a figure in one form or another, either by reflecting over a line, rotating around a point, or translation. That's just sliding it. Okay, and the only thing you got to kind of pay a little bit of attention to is whether the transformations are rigid or non-rigid. Rigid means the shape will hold its we hold its shape when we move these things. We don't adjust the shape, the same orientation. Or the shape remains intact. When the shape changes shape, it's a non-rigid. It says no rigid, it should say non-rigid. And then 7.2 is really about rigid transformations, which are called isometries. So this chapter, very 7.1, 7.2, 7.3, very similar. So reflection across a line, we should understand what that looks like. If you look at this little drawing down here, this would be a reflection. If I drew a line down the middle here of that guy, that's a reflection right there. Rotation around a point, you might have we kind of took a look at that in the day 1 worksheet when we have a reflection followed by a reflection. So we have a point and we want to rotate something this direction, we come all the way over here and it looks like this, and this guy goes, we go around the point, rotate it about the point, and then a translation, we just slide it. Let's take a look at an example of all three. Reflection across the line L. R, if it's on line L, we can't go anywhere. This guy 2 units this way. That means when it reflects over, it'll go 2 units this way. This guy 1 unit, 1 unit. And then when we connect up the lines, we can have something that looks like this guy, and this guy, and this guy. And then one of the big things you need to pull out of this is that a point and its reflection over the line, this I to the new, we'll often call it I prime. When I connect those two, the line of reflection is a perpendicular bisector of it. So when I take a look at T and the reflection, which would be called T prime, this pink line or whatever color it is, that's going to be the same. It's 2 units long there and 2 units long there, and then of course this is on the shape. So when we're talking about the reflected pieces, we would talk about this as I prime and this as T prime. Or if this is the pre-image, the triangle TRI, then the image is T prime, and this one there would also be an R prime here, and I prime. So one of the big things is the point, the pre-image and the image, the points, the segment connecting them, they're perpendicular bisectors as we reflect them over. Reflection usually is something that people are fine with. A little bit more difficult is a rotation, and we'll take a look at how to do a rotation with patty paper in class as well. But if you think about, this one wants us to rotate this guy 270 degrees clockwise. Well, rather than thinking about 270 degrees, which is 3/4 of the way around point Q, we can actually do the other direction. We can do 90 degrees counterclockwise as well. So if I'm thinking about 90 degrees counterclockwise, if you think about what it means to be 90 degrees or perpendicular here, we can make this kind of go down one, left one. We're going to do the opposite. And if I think about this as having to be P prime here, if we take a look at this angle formed here, is going to be a 90-degree angle going counterclockwise, which the opposite of the 90 would be the 270 going the other way. So we can continue with that idea where this is P prime. Okay, L would have to go down to, it's going to end up being right here. There's L prime. A A is going to go straight over 3, which means we'll go straight up 3. Think about the 90-degree angle again. And then R down 1 and to the right 1, 2, 3 would go left 1 and up 3. Left 1 and up 3. That's not right. Left 3 and up 1. P, L, A, R. Where is this one going? Here and here. Yeah, I had it right the first time. R prime. So when I connect these guys up, I get here, 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 here. That's not right. That's 4. Let me fix this. This was down 1, right 4, so it's left 1 and up 1, 2, 3, 4. Used to be there. There we go. Now when we name them up, I get R prime, L prime, P prime, L prime, A prime. Okay, so now we've moved it 270 degrees around this direction, or we've moved it 90 degrees back that direction. As long as you can count the difference between 3 and 4, it makes it a lot easier as opposed to my mistake. Translation, very easy. We're going to move all the points basically up to, right to, if you think about the idea of slope here. So n will go up to, right to. This will be n prime, t up to, right to, t prime, a up to, right to, a prime, p up to, right to, there's p prime, e up to, right to, e prime. Connect them up, and I have my translation, which is just sliding them. These are all rigid transformations. We maintained the shape. We just moved it. We rotated around point Q. We reflected it over line L, and we slid it the same as our line here. Hang on, my dog's got to go outside. Okay, so that kind of, along with what you read in chapter in 7.1, should take care of 7.1. Isometries, rigid transformations. We just saw 3 of them. Here's an example of all 3 again. Number 1 in the blue here is going to be a translation. That's the first type. And then number 2, from here to here, if we're rotating around this point right here, which is actually a reflection followed by a reflection, which comes up a lot as well, we will have a rotation, and the last one, they're flipping, and then actually they're flipping over this axis and then they're sliding as well, but that's going to be a reflection. And those are our 3 types of isometries. Isometries are just rigid transformations. Don't be alarmed by the different terms. Basically means the same thing. Grab your Chapter 7, Day 2 worksheet if you don't already have it. Again, on Chapter 7, Day 2, you can fill out a lot of this stuff on the front yourself. Read the pages. Get that filled in. That's actually for 7.1. But now on the back side, we're going to explore a few of these isometries, and we'll kind of do them together. This has more to do with ordered pair rules. So it tells us. So I have this separated out, and we'll do each of these. But the yours has the 4 graphs. So we're going to start with the one in the upper left, and the top one, which says change the sign on the x-coordinate and leave the y-coordinate alone. So it says take each x, y. So for example, and we don't have to do this with each one, but A is at 2, 1, and when we apply this rule to it, we end up at -2, 1. So that's what this is telling us to do. So here's my -2, 1. There's my A prime. My B prime, we can kind of look at it as 1, 2, 3, 4, 5, which means 1, 2, 3, 4, 5, if I do that correctly. that's B prime. So I've got A prime, B prime. D is going to be right here, and C 1, 2, 3, 4. 1, 2, 3, 4. If I did it right. And then we will draw our figure, and I go A to B, B to C, C to D, D back to A. And then if we want to kind of fill in how it's colored, this is at point B, we kind of have that colored in there, and up at the D we have that colored in there. So it should be we should be able to visually see now the ordered pair rule when I change the value of the x, change the sign of the x, it's going to be a reflection over in which axis is this reflecting over? Over the y-axis. So when we negate the x value, we have a reflection over the y-axis. Next one, we'll do this on number 2. It wants us to take the ordered pair rule, x, y, and leave the x alone, and then we have to change the sign on the y. So again, if we take A as an example, I'm going to end up at A prime, which is A is at 2, 1, and I want to change the sign on the y value, so I get 2, -1. And there's A prime. So you can see if our x's remain the same, if I'm going to do B here, I'm still going to be at 1, 2, 3, 4, 5, but now my positive 2y value goes to -2, and there's B prime. And then C, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Since the x value stays the same, I can stay on that same vertical line. That's C prime and B prime, and here's A prime, and now D prime. 1, 2, 3, 4, 5, 6. So it's at 1, 6, so I'm going to go to 1, -6. 1, 2, 3, 4, 5, 6. And now when I connect the dots, A to B, B to C, C to D, D to A, color in where we have, color in where we have some color. Whoa, what happened there? Undo that guy, that's for sure. When we color in B, how that's colored, and color in D, how that's colored, and that's D prime. We can hopefully see that now this is again a reflection over but now we're going over the x-axis, right? X-axis. So when we negate the y-coordinate, change all the y-coordinates, the signs of all the y-coordinates, then we're going to end up with a reflection over the x-axis. Okay, next one. We're starting to get a little bit different now. Let's see, did I have... Okay, yeah, the next one is we're going to change the sign of both of them. So again, if we want to kind of take a look at A being 2, 1, if I'm going to change both signs, then after my isometry or transformation, I will end up with -2, -1. So since I'm in quadrant 1, we're going to end up with all these things being in quadrant 3, which isn't always the case. It just depends on where your pre-image starts. So I'm at 2, 1, so I'm going to go -2, -1, and there's A prime. And then B, 1, 2, 3, 4, 5, 2, so I'm going to go -5, -2, and there's B prime. And then C, 1, 2, 3, 4, 1, 2, 3, 4, 5. So -4 and -5. And I'm at C prime, and then D is 1, 6, so this is -1, -6. Again, I can connect them up, and we have a nice little guy here, and we fill in the B, because the B has the Oops, I need this guy. The B has the little, and the D has that. So when we change both signs, really, if we kind of look at it, we could look at it as the reflection over to quadrant 2 changes the X, and then the reflection down when we change the Y's, or we could look at it as the Y's first and second. But this is actually going to be rotating around this point. This is a rotation around about the origin. So you can see D started there, ended there. A started here, ended here. B started here, ended here. Notice how many degrees is this rotating? They're on the same line. They're rotating 180 degrees about that origin. D goes from here, comes around, ends here. It would be on a straight line. A's on a straight line. B's on a straight line. And if this is a reflection across the y-axis and then the x-axis, and that's a right angle. That right angle meant a rotation of 180 degrees. Coincidence? I think not. I think we'll find more out about that as we continue on. Last one is a little bit different. It wants us to take my xy coordinates and interchange the x and the y's. So this is going to be a little bit different now than the other three that we did. So when I take point A at 2, 1 and interchange them, I get A prime at 1, 2. We better take a look at a couple more of these. B is at 1, 2, 3, 4, 5, 2. And when I interchange the x and the y's to make a new ordered pair, I get 2, 5. And then C, I'm going to take, what's C? I think it's 4, 5, if I remember correctly. And I interchange that for C prime, I get 5, 4. And then D was 1, 6. And I interchange those for D prime and get 6, 1. So let's start with A, 1, 2. It ends up right here. Interesting. A prime, I'll kind of put it over there. B, 2, 5. 1, 2, 1, 2, 3, 4, 5. I'm kind of on my, I'm right on my other figure, which is a little bit of a pain. C was 4, 5. It's going to be 5, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. It ends up right there. C prime. And D was 1, 6. Ends up 6, 1. It ends up way over here. D prime. Now when I connect these up, A prime to B, B prime to C, C prime to D, D prime to A, color in the B in the little corner, color in the D in the little corner, and then we got to figure out the ordered pair xy goes to yx is a blank over the blank. Now, if you noticed in the last one when they told us it was a blank about the means it's going to be a rotation. When we take a look at over, this means it's going to be a reflection, but what the heck are we reflecting over? It's important to note that if I was interchanging my values, if one of these was, say we had a point at 4, 4, and I interchanged them, I would still be at 4, 4. And what is the significance of 4, 4? The x-coordinate and the y-coordinate are the same. So this is actually going to be a reflection, and you still may not see it, and that's okay, over the line y equals x. So if I draw in the line y equals x, watch this. That's going through the points 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. And now you can see reflection. Each pre-image and image point will be perpendicular bisected by its line by the line going through it. And if you take a look at A and A prime, B and B prime, you can see that they're going to be on the same side of that line, y equals x. So the moral of the story, when we interchange the x and y coordinates, it's a reflection over this line. When we negate both coordinates, it's a rotation, because it's a reflection followed by a reflection, which is a rotation. When we interchange the or when we change the sign on the y coordinate, we reflect over the x-axis, because the y is going to make us go up and down, and the x's make us go left and right, so it's over the y-axis. So those are 4 concepts that will continue to come up through Chapter 7. I don't think I'm going to spend that much time on this. You can do these. Take a look at these ones on your own. I see a negate and a negate, which means this is going to be a rotation about the origin. So you would take 2, 1 and go -2, -1. You'd take 2, 3 and go -2, -3, which would be here, and you'd take 5, 1 and go -5, -1, and you would have your line that looks, or your rotation around the origin there. We're not doing anything to the x and anything to the y. We're just moving it 4 left and 6 up. If you're just moving something 4 left and 6 up, this is a translation, and it would be 4 left. We'd move everything 4 to the left and everything 4 up. Now this one, they're trying to trick you. This is -x plus 4 comma y. If we look at it like this, we can see that we're negating the x. Y is staying the same. So we're negating the x, which will flip us over the y-axis, and then we're sliding it 4 units back to the right. So this is actually, there's more than one thing going on here. We would call this a reflection, but it's a reflection followed by a translation, because there's 2 things taking place. So the first thing we are doing is we're changing the sign, flipping it over. So for example, this point down here is at negative, let's say -3.5, or it's -4. So we're gonna, or excuse me, it's 4. We're gonna go back to -4, but then we're gonna go 4 to the right. This one would end up here. This one is at -2. We're going to go flip over to the 2, and then we're going to go 4 to the right. So I end up there. This guy up here is going to go to -4 and then go 4 to the right. So I end up here. So when we draw this guy up, we go from here to here to here to here. So it doesn't look like the true reflection that we had when we went over, but this is what happens too when I have coordinates on both sides of the y-axis. So we're 4 minus x, the negative is attached to the x, which means it's a reflection. We flip it back over, and then we move it 4 to the right. And that's what we get to. These are all rigid transformations or isometries. You can do this one with patty paper, but you get an understanding of what we're going to do here. Let's just take a look. We'll kind of draw it up. You may want a ruler for this as well. These can be done with rulers. But can also be done with a patty paper. When you're going to reflect something on patty paper, all you have to do is put the fold on the line you're going to reflect over. For example, if I'm going to reflect over this line, all I'm going to do is I'm going to trace this, and then I'm going to fold right here. This guy will end up there being reflected. So the shortest path is called the minimal path. This is the shortest distance the cue ball has traveled to hit one cushion and then hit another. So if I want to shoot from here to here, I would hit the corner, so I need to bank it. The easiest way to do it is to start with the ending point. So let's reflect the ending point up over the top. Now, if you remember what we talked about lines of reflection, this distance right here, the distance from here to here, is going to be a perpendicular bisector, and that's going to be equal then to the distance up to there. So I kind of drew that guy there. That's going to end up where my reflection will be. I'm rough sketching this, but whoa. I'm going to move that out of the way. So now when we are going to shoot the ball towards, what we do is we shoot the ball straight towards this guy up here. But what happens when we hit the rail? We're going to bounce. So I want to go till I hit that guy right there. And now that distance turns me this direction, and I will end up hitting right there. So this distance right here, let's call this distance right here x units. Notice if I was to continue going up with this guy right here, those two distances, the distance from here to here and from here to here, would be exactly the same, because all we've done is we've taken this and swing it down there. That's why it's called the minimal path. Even though I can't get directly from the ball to the hole, I can go and bounce it and come down, and that's the minimal path distance. Now, so you can show that on patty paper as well. What if you wanted to get fancy and bounce it off of 2 rails? If you want to get fancy, then 2 rails requires 2 reflections. So again, I start at the ending, and I'm going to reflect it over this line right here. So that distance, if I reflect it out here, so now I reflect it over this rail, and now extend this guy out, reflect the reflection. So if this is the pocket, we'll call it P, this is P prime. When I reflect the reflection, I end up here. Is that? I need to be a little bit further, I think. Right there. That'll be P double prime. Okay? So on patty paper, you could reflect over this one and then reflect the reflection up there. And now when we shoot the ball, always going to start, and we're going to shoot it straight at the P double prime, if I could kind of line that up, which will then turn me over towards P prime, which then turns me back, and I put it in the hole, and everybody's very impressed. So whenever you want a minimal path where you have to bounce something, you want to, if you can go in a single bounce, it's a single reflection. If you want to go double bounce, it's a reflection followed by a reflection. Here's 2 problems where it says that the class is holding fence races. You must touch each fence at some point to get from S to F. I'm guessing that's start to finish. So the first one, you just got to touch one fence. So again, I kind of always like to go to where you're ending. I'm ending at this finish. Let's reflect that finish. So that distance will be equal to the distance over here. So I reflect that over there. That would be called F prime. And now when I take and I shoot my, I start running, the shortest distance that we would have to run, I should run directly at that reflection, which will then bounce me and run me directly over here. And again, this distance right here, assuming I'm in a straight line, is equal to the distance right here. This distance here, if this was x units, this is x units. Does it work if you wanted to reflect the s? Well, sure it works. I can reflect the s over to here and get s prime, but now you're tracing backwards. See that? You're tracing backwards because this f would then, starting from there, you would run up there. So it works either way. Now I need to hit 2 fences. I'm starting here, I'm finishing here. If I've got to make a double bank, I need 2 reflections. 2 fences means 2 reflections. So first I'll reflect down here, get F prime. Then I'm going to reflect the reflection, which will be about over fence 1, which will be about over here. I just, again, patty paper will get you more exact on this. And now when I take and start at my start, I run directly towards that guy, which then turns me directly towards F prime, which then turns me directly towards the finish, and I go boom, boom, boom. Again, that distance would be the same as those 2 combined. That distance would be the same as that one, and we get from start to finish. So that's the basics of 7.1 and 7.2. Biggest thing is transformations, which have translations, which is sliding, reflections, which is mirror image, and rotations around a point. And now you should be able to work on your chapter 7 day 2 and get that guy done.